Okay, students, look now at this question number 6. We have a spring hanged with a mass. The mass is 25 kilograms, and the spring constant is 800 newtons per meter. The main formula I think we will use in this question is omega, which is the angular velocity, or the angular frequency. We can name it angular velocity or angular frequency, which is equal to the root of k over m, which is equal to 2 pi f is the frequency, which is equal also to 2 pi 1 over t, because the frequency is equal to 1 over t. Now we need to find the period t, the time that this mass need to go a total oscillation. Okay, t from this part and this part. We can find that t is equal to 2 pi m over k. Okay, 2 pi is known, m is 25, k 800 under the root. It will be equal to 1.1 seconds. So the period, every 1.1 second, the mass go down and go up to reach any point. If we start from here, the mass will go down and rotate to move to reach this mass, this point again. Okay, what is the angular velocity or the angular frequency? It is 2 pi over t, or it is equal to the root k over m. I will use the both formulas. It will give me the same magnitude, 5.66. And the actual magnitude of this frequency or omega is equal to 5.6568542 and some other terms. Okay, this is important in the next part. Maybe you will approximate it to 5.7. Maybe you will approximate to 5.66 or 5.65. We approximate this to here to 7. Now we need to use the formulas of the position and velocity and acceleration. If the amplitude is the maximum distance that the mass move, okay, it is not the total distance, it is half of it, which is a, and this is minus a, you can call it, or another a. If a is 12 centimeters and we have a time, certain time, arbitrary time, it is 18 seconds. The period is 1.1. It is different than this time. We need to find x of t at that time. So the formula is, use this, x of t is equal to the amplitude a multiplied by cosine omega t. We know t small, which is 18. We know the amplitude, it is 12 centimeters. We don't need to change it to meters. If you need to do that, it is okay, but there is no need to do that, because when we find the final answer, we can put it in centimeters. It's okay. We don't have newtons, we don't have joules. Newton and joules and some different physics quantities in physics should have meters and seconds and kilograms, but in this case it's okay. We just need to find this distance. Okay, look here, and you need to be sure that you are working in radians with your calculator. Okay, with radians, omega in radians per second, the time in seconds. Now if I take the first value, 12, a, it is 12, cosine, omega t. T is 18. Omega I approximated to 5.7. The answer will be negative 5.734 and so on centimeters. But what if I take it more accurate, which is 5.66? I approximate to the second decimal point. I will have another value. I have the time is the same and the amplitude is the same, but I change the approximation degree. I have another distance. Look, negative 5. That means it is negative 5. 2.6. This is 2.6. Okay. Now, if I take another degree of accuracy, it will be 5. This is omega 657. Here, that distance will be 3.267. It's different. It is more than the second one. If I take the full approximation of or full quantity I have, it will give me 3.297. And what I need to ask you, this is the more accurate one. It is 3.29, approximately 3.3. So it will be positive value 3.3, not negative 5. If we take it, if we take that omega is 5.7, it will be negative 5. It will be here. That means a different bit of omega. That it will change the position of the mass. If I change another omega after 18 seconds, this approximation will be magnified by 18 times. But if I take it just one time, if I take the time is 1, then this approximation will not be affected. But 18 times it will be magnified, and the error in my calculations will be from positive 3 to negative 5. It will be 8 in magnitude. Why is that error appeared in this formula? Because this is cosine, and cosine is a periodic function, and it is fast in our case. It changes its direction and its position in fast way, and we use radians. If we use degrees, it will not be that difficult. But in radians and cosine, it will be fast periodic function. And if we change the approximation for 18 times of magnifying, we magnify this error. Look at the difference between this and this and this. It will be magnified 18 times. And this error will be more if we have the time is bigger than 18 seconds. Okay. Now D. We need to find the velocity at the same time. T is equal to 18 seconds and the amplitude is 12 seconds. 12 centimeters, I'm sorry. And omega is the same. We need to remember that these formulas these formulas are given to you in the exam. The position is equal to A cosine omega t. The velocity is equal to minus. If you are a physicist, you can know why these formulas are in this way. It is just the derivatives. If we derive x with respect to t, it will give you velocity. If we derive the velocity, it will give us the acceleration. And this is the formula of the acceleration, and it is the same, minus omega squared multiplied by x of t, because A cosine omega t is x of t. This by the same way. If we have approximation for omega, we will have different values of angular for the velocity of the mass. We are talking here on the mass, velocity of this mass. Maybe this velocity be in the negative direction or in positive direction. Look, for omega is equal to 5.7, the velocity is negative 60. that means it is to downward in 60. If we have more accurate value, it is minus 66. Okay, if we have more accurate, it will be minus 65, minus 65.26, and so on. This is the most accurate value. And the same for the acceleration. If we have the acceleration is a omega squared multiplied by cosine omega t. We have omega here. And for the velocity, we have omega before the sign also. If I change the value of omega to a more accurate value, I will have different values of the acceleration. Look, the first one with omega 5.7, it is 186 centimeters per square second. Now look at here, I find the units in centimeters per second. It's okay. I don't need to change it to meters per second. Okay. In this case, if I take a more accurate value for omega, it will be negative 84. But here 186, positive and large magnitude. Look at the third one. It is negative 104 centimeters per square second, and the most accurate value is negative 105.5 كذا centimeters per square second. In this case, we find the position, the velocity, the acceleration for a vibration system, but we need to be careful about the approximation for our value. Okay, solve this question and all the question by yourself, by your hand, using a pen. Thank you.